Hi everyone. Let's take a look at questions 9 and 10. They're similar to each other except that one uses a calculator and one does not. And talk about how that relates to this idea of differential equations and initial conditions and all of that. So this first one is with a calculator, but we're going to do a lot of the setup by hand and then just use our calculator to calculate integrals and derivatives. It gives me an initial position, that's an initial value, and it says the velocity of the object is given by this function here, okay? And so it says, what is the position of the object at time t equals 4 seconds? So here's big idea, right? We know the position at x of 0, or we know the position at 0 seconds, I should say, okay? And what this question is asking is, what is the position at 4 seconds, okay? This is what I'm trying to find out. So what I need to know is how much did my position change by, okay? And change in position, that's an integral of the velocity function. That's what integrating velocity tells me, is how much overall change in position has occurred, okay? So if I were to calculate that change in position, I would then take it and add it on to the 2, or if it's negative, I would subtract it, and then figure out where this ends up. So watch how this function is going to lay out. I'm going to say that my x of 4 that I'm trying to find is going to be this 2, and then I want to integrate from 0 to 4, and I'm integrating starting at 0 because that's the value that I have here, right? I know that the initial value at 0 is 2, so I'm starting from 2, and then this will tell me how much did my position change from 0 seconds to 4 seconds, okay, of the v of t function. What's nice about this is this can go right into my calculator. So I'm going to do this in 2 steps. You could actually type it all in with the 2 plus and everything, but I'm going to do just the integral here for a second. So I'm going to do math 9. I'm going to integrate from 0 to 4 of this velocity function, which is sine of pi over 3x. And just to remind you, let's see, I thought so. Yep, I'm not in radians, I'm in degrees. That answer did not seem to make sense. Should have checked that. There we go, that looks better. That's what this integral should look like, okay? And this is this. This is how much did my position change in those 4 seconds from 0 to 4. Okay, so what I want to do is I want to take 2 and add it to that change in position. I want to take 2 and add it to that number, and this is what I end up with, is 3.432. And this is, I guess I don't have units on here, so I'll just say units. Okay, let's compare that with this question down here at number 10. Okay, number 10, now this one we have to do without a calculator, which means I can't take this nice shortcut where I can just integrate this by hand, or with a calculator, but the method is the same. And the method is the same for this question. Find the position at t equals 5 seconds. Okay, so really what I want to do to answer that, and I'll come back to this thing in a second, but what I really want to do to answer this thing is I want to say that x of 5 is equal to, now at 2 seconds, the position of my particle is 7 centimeters, so I'm going to start at 7, and then I'm going to integrate from 2 to 5, because that'll tell me how much did my position change from 2 seconds to 5 seconds. Okay, so this is of the v of t function. So I'm integrating again from 2 to 5 because this was at 2 seconds. So I could have written it the same way here. I know x of 2 is equal to 7, and I want to know x of 5. So what I need to know is how much did it change by from 2 seconds to 5 seconds, and that's what this integral is going to do for me. Okay, this time though, I can't just type this integral in on my calculator because this is a without a calculator question. So I need to think about how do I evaluate this integral by hand. Okay, And so I think I'm going to move to separate paper for this just so I have room to spread out and write everything that I'm doing. And so the problem that I'm trying to do here now is an integral from 2 to 5 of x plus 3 over a square root of x squared plus 6x. Okay, this is what I'm trying to get to. Okay, if I had handed you this problem 2 weeks ago and said, hey, figure this out, first thing you would have done is try to find an antiderivative here. And to get an antiderivative of this one, I'm going to need to use u substitution. So I'm going to say that u is x squared plus 6x. So du is equal to 2x plus 6 dx. And then swing this to the other side, and I would end up with 1 over 2x plus 6 du equals dx. And then I'm going to replace that up here. Okay, so now my integral is going to say, I'm not going to write the 2 and the 5 right now because, remember, I want to maybe adjust my endpoints here later on. So I'm going to say this is x plus 3 over the square root of u times 1 over, and I hope this doesn't bother anyone, but I'm going to take that 2x plus 6 and write it as 2 times x plus 3, because what I really want to have happen now, so just to kind of hit this a little harder, the reason I'm doing u substitution is I can't integrate this in terms of x. So I'm writing it in terms of u so that I can hopefully get to something that I can integrate. But I can't integrate right now with these x's in here, and so I designed this so that my x plus 3's would cancel out. So now what I have is 1/2 times the integral of, really I have 1 over the square root of u, which I'm going to think of as u to the negative 1/2 power. But I can integrate that. I know my integral rules for that, and I'm integrating in terms of u, so that's what I'm allowed to do here. Okay, so let's do that. My integral is going to be 1/2 times, that 1/2 just comes from here. I'm going to add 1 to this exponent, so that's going to bring me to a positive 1/2. And then I'm dividing by 1/2, or you can think of it as multiplying by a reciprocal. So this is going to be 2 over 1 out in front here. Well, those cancel, and so what I'm really left with is u to the 1/2 power. I have a choice here. I can either say, here's my vertical line, and I'm going to adjust my endpoint, so I could put my 2 and my 5 in here. Or I could go ahead and turn this back into something in terms of x, and I think that's what I want to do because of the next thing that I know I'm going to have to do with this problem, is I'm going to say this u to the 1/2 is really this u value with a square root on it, right? So it's really the square root of x squared plus 6x. Now, I just want to make it clear that, like, this should have a plus c on it. I'm going to have to worry about that plus c in a minute. For right now, I'm going to evaluate it at endpoints, and so I don't really care about the plus c. Okay? But the plus c will matter eventually. So now I can take, I'm just switching colors all over the place on you, this square root of x squared plus 6x and evaluate it going from 2 to 5. So that's going to be square root of 25 plus 30, so square root of 55, okay, minus square root of 4 plus 12, so that's 16, okay. So altogether, I'm going to say this is square root of 55 minus 4. That is my integral value, okay? So that is how much did my position change from 2 seconds to 5 seconds, okay? This is how much distance I covered, or how much it's my displacement, okay, between 2 and 5. So let's go back over here, okay? If I'm trying to find my position at 5 seconds, this is saying I need to do 7 plus this integral value, which is what I just calculated, right? and I just calculated my integral at square root of 55 minus 4, and then I could put the 7 and the 4 together and just say this is 3 plus square root of 55. This would be my position at 5 seconds. Okay, so at 5 seconds, this is where I'm at. Okay, that didn't actually get me to a position function, right? And like technically back here, it didn't ask me to write a position function. If it had, I would have had to integrate this by hand. The calculator is only really helpful for doing definite integrals, which is when you have endpoints. Okay, if I want a position function, I'm going to have to be a little more general. So let's talk about writing a position function for this problem. And some of the work we just did is going to be helpful, but okay. So if I want my position function, I still want to integrate velocity. So what I really want to do here is find an integral of this x plus 3 over square root of x squared plus 6x. The only reason this does not give me position by itself is because of that initial value, that initial condition. Technically, this gives me change in position. I need to anchor that to some sort of initial value, okay? And so I already know what this integral is. We did all the work up here. Like this is where we found out that this was our indefinite integral. Notice I don't have endpoints here. So I'm just going to say that this is square root of x squared plus 6x. And then this should have a plus c on it, okay, if I want my position function. Well, to figure out what that c value is, which I guess back here I could have this labeled, this is my x of t function. I can take one of the values that I know, which is that at 2 seconds my position is at 7, and I can plug it in. So my position is at 7, square root of x squared plus 6x. Oh, sorry, I didn't mean to make those x's. I want to make those 2's. So 2 squared plus 6 times 2 plus c. Okay. This is now 7 equals the square root of 16 plus c. That's a 4, and if I subtract it, I get that my initial value is 3. Okay. And so what that tells me is that my position function, x of t, is always going to be this square root of x squared plus 6x, which I found through doing u substitution, and then it's going to have a plus 3 on the end, or you could have it in front. You could have 3 plus this square root function. This is my position function, which if you think about it, this question that I just did, I started with this one by doing the specific value at 5 seconds, and I did that just because it was really similar to the one we had done up here. But if I had done this first and found my c value first, which I think is how I did it on my answer key, then when I wanted x of 5, I would have just plugged in a 5 and said 5 squared plus 6 times 5 plus 3. That's square root of 25 plus 30, so that's square root of 55 plus 3 is x of 5. And that's exactly the answer we just got. Okay? So it really doesn't matter which way you go. Like we got this answer, we would have gotten this answer this way. If you want to do the function first, or if you want to just find the position at 5 seconds, that's fine too. But as long as you understand that when you're integrating from point to point, what you're really figuring out is how much did your position change in that amount of time. And when you want a position function, this number on the end should really be like what is your position at 0? This is your initial value, meaning at time 0. And that's really what we did here when we did this whole, like, we have the 7, but then we subtracted the 4 and all of that. That was us finding that initial value. Okay? But those questions are essentially the same thing. They're asking me the same type of thing. Let's just throw back up here to letter B. How much total distance have I traveled? Well, the integral of velocity is telling you how much distance how much your position has changed by. But remember that total distance means we don't want to count anything as being negative. These are way easier with the calculator. It's after 4.5 seconds, so I want to go from 0 to 4.5, and I want to do the absolute value of that velocity function. Okay, again, I'm just going to do that in my calculator. So remember a second ago we said that from 0 to 4 our change in position was like 1.432. What I really want to know is, like, was that all positive or was there some negative mixed in there? And that's what this is going to tell me. I guess this is going to 4.5, but this is 0 to 4.5, 4.5. And then I'm typing in my function, which is sine of pi over 3x dx. Oh, I forgot my absolute value. Sorry, guys. That's what happens when you see me do this live. So 0 to 4.5, I need absolute value to get total distance. So absolute value of sine of pi over 3x dx. Takes a second because that absolute value throws it for a loop sometimes. But this is the total distance that I traveled, 2.865. And I don't know what that velocity function looks like, but if my velocity function does something like this, my total distance is saying I'm going to count this as positive and I'm going to count this as positive, and my net total is the 2.865. Okay? This value, when I did that integral and got the 1.432, it was combining this as a positive and this with a negative. Okay, I think you can handle speeding up and slowing down. You're just doing v of 2, and you're just typing that into your calculator, and then you're doing v prime of 2 for acceleration. Remember, this can also go into your calculator as math 8, because you can do the n-deriv function. Okay, so just don't forget that you can do derivatives and integrals on your calculator for those.